So the second lesson we're going to take a look at is from section 2.1. Okay, we'll spend the rest of the week on this section, and it has to do with angles. So there's different ways you can measure an angle. Does anybody know the units? I'm guessing that a lot of people are familiar with for measuring angles. We measure them in feet or inches, or like, what's the unit, Vivian?
Degrees.
Yeah, a lot of people are familiar with degrees. There's another way that we measure angles as well. It's called radians. And we're going to talk about how you can convert between degrees and radians. So we'll go through that. And then first I'll just talk a little bit about what's an angle, kind of in general. And then we'll get into how we measure them. So the very first thing when you're going to talk about what an angle is describing a part of an angle, which is called a ray. So a ray is basically a line segment that goes on forever in one direction. So it has a starting point and it continues in one direction. The point where a ray starts is called a vertex. That's a ray. And I said that extends in one direction forever. Now, if you take two rays and you put them together, so let me draw another ray. And you specifically line them up just like that. You put two rays together at a common vertex. Okay, so the starting points overlap. Now you've created what's called an angle. Technically, you have two angles. You have this one on the inside, and then you have another one on the outside. Generally, we're going to be referring to the one that's less than 180. So that would be the one that's inside. And there's another example. Putting two rays together and making an angle. So that's an angle when we're talking about an angle by itself. You can also have an angle that's part of a shape. Now those aren't rays. Those are three line segments. But we still call these three things angles. Even though they're where two line segments are coming together, they're not two rays. Okay? So you can have an angle that's all by itself, and that's where you've got the two rays, or you can have an angle that's part of a polygon, and that's where line segments be. Still called an angle. Okay, any questions on that? All right. So an angle really has these two rays, and we call them the sides of the angle. One side is the initial side. The other side is the terminal side. So we need a way of kind of understanding, well, how do you know which side is which? Here's another example. The way you can tell which side is which is if you rotate counterclockwise, starting at one side and going to the other side. The one you start at is initial, the one you end at is terminal. So if I had my angle drawn like this, I go in between the rays and I rotate counterclockwise. Where you end is the terminal. Where you begin, that's the initial. Now, we're going to have an even easier way to tell which side is initial and terminal besides this rotation thing in a second. This is generally how you want to draw an angle, not like I did on the right. There's something about this one on the left that makes it a little nicer than this other one. And it has to do with how you draw the initial side, like how you have it rotated. But I'll talk about that in a little bit. Any questions on that so far? So, when we start to talk about measuring an angle, whether we're going to measure in degrees or radians, there's two directions you can measure in. Depending which way you measure is going to give you a different answer. So when you measure an angle, if the rotation from the initial to the terminal side is counterclockwise, so in other words, if you go this way, that's what we call the positive direction. Okay, so counterclockwise, that's a positive direction. If you go the other way from the initial to the terminal side, let's say you go this way, initial to terminal, and you were to try to measure something like that, that's going to be a negative direction. So counterclockwise is positive, clockwise is negative. Okay, I'm going to show you guys an example of something like that right now. All right, so let's take a look at what I kind of mean about that positive versus negative rotation. So here's a program where I can't move the initial side, but I can put the terminal side anywhere I want. Notice the direction I'm moving is counterclockwise, and the angle is being measured as a positive number. Okay, put it back at 0. If I go in a clockwise direction, now it's measuring the angle as a negative. Okay, so anything going in a clockwise direction from initial to terminal would be a negative. Counterclockwise from initial to terminal is a positive. Okay, question on those two directions. You also see two numbers in the lower right. Well, it might be a little hard to see, but the top one is degrees, 152, and there's a little degree symbol on it. Notice the bottom one is just a number. There's nothing. There's no label. There's just a number. There is a label here, but it's invisible. Okay, we don't write it. And we're going to talk about that bottom number in a little bit. So I told you that there's a kind of a standard or a normal way that we draw an angle. The way on the left is good. The way on the right, not really as good. And the normal way that we draw an angle is what's called standard position. An angle is in standard position if those two things happen. Okay, the two things are, 1, the initial side is on the positive x-axis. 2, the vertex is at the origin, if you had like a coordinate plane. So that angle that I've drawn in red right there, that is standard position. How about now? Is that angle still in standard position? Don?
No, because the vertex is not the origin.
The vertex is not at the origin anymore. That's not standard position. Okay, how about if I did something like this? Is that standard position? What do you think, Ben? What do you think?
There we go.
What's that? What do you think? Is that a standard position? Ben? Yeah, is that standard position?
Yes.
How come? What are the two criteria that it has to meet?
The vertex is at the origin.
Okay, is the vertex at the origin here?
Yes.
I agree. All right, what's the other thing it has to have?
It's not because the initial side isn't on the positive x-axis.
Correct. The initial side isn't on the positive x-axis. It looks like the terminal side is close to the y-axis, but that doesn't mean anything. Right? The initial side has to be down on the axis, just like that. And that's an angle that's in standard position. Okay. Any questions on that? All right. So now we talked a little bit about angles. Now we'll talk about how we measure things in radians. All right. So the big thing we're going to want to be able to figure out here is how do we convert between degrees and radians. What if we wanted to convert between, say, degrees, or not degrees, let's say inches and feet? How would you teach somebody or explain to somebody how to convert between inches and feet? What would you have to explain to them? Yep.
Like the amount of inches divided by 12 and whatever the remainder is extra.
Okay, so what do you mean divide by 12? Where's that coming from?
Because 1 foot is 12 inches.
Exactly. In order to convert between two things, you need to know a conversion between the two things. You have to know something to start with, right? I didn't tell her that in 1 foot is 12 inches. She told me that. So in order to convert between degrees and radians, we're going to have to figure out the same kind of thing. We're going to have to figure out how many degrees in how many radians. We have to start with something. Once you know something, you can figure out anything you want. So if you know that there's 12 inches in a foot, you can convert 37 inches to feet. You can convert 96.5 inches into feet. All because you know a fact about inches to feet. And any fact would work. She said 12 inches is 1 foot. Fine. She could have said 24 inches is 2 feet. That fact would work just as well. But the one she said was simpler. 12 inches, 1 foot. So that's going to be our goal. We're going to have to fill in this question mark and figure out how many radians in that many degrees. Or how many radians in 180 degrees. Or how many radians in 90 degrees. The point is I need something. How many radians in a certain number of degrees. Right? And that's what we're going to try to figure out. So the first thing I'm going to do is just try to explain what a radian is by showing you a picture. Now, if you look at the word radian, does that word kind of look like any other word in math? Aiden?
Radius?
Yeah, it kind of looks like radius. So in the description of a radian, I'm going to use the word radius. I'm going to start out with this diagram. What I've drawn here is what's called a central angle. It's an angle that has its vertex at the center of a circle. And it has two rays, which are the radii, coming from the center of the circle and hitting the edge of the circle. In between where the two rays hit the circle, they form an arc. An arc is part of the circumference of a circle. If you make the angle bigger, you'd make that arc bigger. If you make the angle smaller, the arc also gets smaller. Now, if you make that angle exactly the right size, so that the length of the arc in red is exactly the same as the length of the radius. Okay? It doesn't have to be. But if you make it so that that arc is exactly the same length as the radius in black, then what you've just drawn is a picture of 1 radian. So that doesn't answer the question about how many radians are in a degree. It's more of a visual to think about what a radian would look like. Arc that's exactly the same size as the radius. All right, any questions on that? All right, so now I'm going to tell you guys a certain fact. Okay, just we got to start with some fact about this, and I'm hoping that we can use that fact to figure out how many degrees in how many radians. That 1 foot 12 inches. I'm trying to figure that fact out for radians and degrees. And that is going to be the starting point for how we figure it out. That sentence right here. Okay, so that says an angle's measurement in radians is numerically equal to the length of the arc on a unit circle. So I explained to you earlier what an arc is. Okay, an arc is what I have drawn in red right there. A unit circle is a special circle. Particular, it means that it's a circle where the radius is 1 unit. All right, so let me see if I can give you a visual of that sentence. All right, so let me. All right, so I have a ruler. I should just sign that.
Oh, I have one.
A piece of paper is fine. So I put a ruler up on the screen. I know it's big, really bigger than 1 inch, but it is what it is. So I'm going to draw something that's exactly 1 inch long. Okay?
I don't have any paper either.
Right in the back, under the TV. So I got something exactly 1 inch long. Okay? I'm going to make a circle where that is the radius. Yep, can you fill that for me?
Yeah.
So I just made a circle that has a radius of exactly 1 inch. I know it's bigger than 1 inch, but that's the size of my ruler. It's a big ruler. It's for giants. Okay. All right. Any question on that circle? All right. So now, let me draw, let's see, another ray in that circle. I'm going to draw one like this. Now, how long is the radius in the circle? Yeah, it's 1 inch. It's 1 inch. Now, if I do have a protractor, let me see. I don't know if I have a protractor that I can really use. Let me see. I think most of the protractors on here measure in degrees. Let's see. Pictures. Yeah, that's degrees. That's not super helpful. That's the same protractor. see this one. That is a different protractor, but it still measures in degrees. Alright, so we're just going to have to pretend. So let's say that I measured this, and I had a protractor that I could use, and I measured this angle from here to here using my protractor in radians. And let's say that that came out to 1.6 radians. I'm just making up 1.6. I don't have a protractor that I can use to do it. But let's say that that came out to 1.6 radians. Based on, just move these out of the way, based on this sentence, the angle's measurement in radians that I just did was 1.6. This sentence says that that's going to come out the same as the length of the arc. That means if I took a string, put it right there, and measured it, that distance right here would come out to exactly 1.6 inches. That happens because I drew a circle that had a radius of 1. The size of this angle, or the measure of this angle in radians, comes out exactly the same as the length of the arc. Always on a unit circle. If this was 5.2 radians, this would be 5.2 inches. If this was 0.4 radians, this would be 0.4 inches. The angle size and the length of the arc always come out the same on a unit circle. Always. Any question on that? So, what's a number that comes up a lot when we deal with circles? Kind of a special number in math. Don?
Pi.
Pi. In particular, 2 pi, right? 2 pi comes up a lot. Does anybody remember what 2 pi is used for? There's a formula in math involving a circle, and 2 pi is in the formula. It calculates something about the circle. You remember? Yeah, JD?
I think I remember the formula, but I don't remember what it's used for. I think it's like 2 pi r squared.
2 pi r. Pi r squared is a different formula, but 2 pi r, the first part of what you said, is the formula to find something in a circle. Anybody remember what that is? Yeah.
Is it the diameter?
Not the diameter. Close. If you wanted to write this formula with diameter, you could write it this way. But these both equal the same thing. Yep.
Circumference.
The circumference. Either way. You can think of it either way. I'm going to think of it the top way. So the circumference of a circle is 2 pi r. So here's the key at how we can figure out how many radians in a circle. If you can tell me how big that is, that's the circumference. But we know that the size of the circumference is going to come out exactly the same as the size of the angle. So if I know the size of the circumference that goes all the way around this circle, then I will know the size of the angle that goes all the way around the circle. More importantly, I'll know the size of the angle in radians that goes all the way around the circle. Right? So let's figure out the size of this green line that goes all the way around the circle. What's the radius in this circle? Right?
I have no clue.
Well, I measured it. Remember I measured it earlier?
Yeah.
What did I measure that to be? Actually, it's labeled on the board too. How much?
1.7.
So that's the size of this angle. That's not the radius. Yep. 1. Radius is 1. So let's plug in 1 for my radius, and let's find the circumference of the circle. 2 pi times 1. I'm not going to round it. I'm just going to leave it like that. So this circle has a circumference of 2 pi. So now I know how big this thing in green is. It's 2 pi. So what does that mean that the size of the angle would be that goes all the way around the circle? Remember, the size of that length of that arc that I did in green is the same as the size of the angle. So if the length of the arc in green is 2 pi, what's the size of the angle that goes all the way around? Yep.
2 pi radians.
Exactly, 2 pi radians. So, don't need that. Now, we have a fact about degrees and radians. Just like having a fact about 1 foot equals 12 inches. Now we can do anything we need to, because we know how many degrees in a certain number of radians. We're going to try to make this fact a little bit easier to work with. This is kind of like saying in 3 feet there's 36 inches. Although it's true, you can simplify that fact a little bit and make it easier to work with. So let's get right up here. Let me copy down what I wrote. 360 degrees equals 2 pi radians. What could I divide each side by to make this a little bit easier at least? Yep, Tom?
2.
We can divide each side by 2. At least it makes it even a little bit easier. And now, when you give someone a conversion, what number do you usually have in the conversion? This number makes it easy for someone to understand what you're trying to convert. Like, you don't normally say 4 feet equals 48 inches. That's confusing. You reduce it. But when you reduce a conversion to be as simple as you can, it usually has what number? Yeah, let's see, Olivia?
1.
1. Pretty much any conversion you ask somebody, they're going to put a 1 in it. Right? 1 hour, 60 minutes. 1 hour, or 1 day, 24 hours. You don't usually say in 2 days there's 48 hours. There's a simpler way to say it. So, depending on, we can put a 1 on either side. We're going to have to do division. Depending on what side we put a 1 on, is going to control whether we're converting degrees to radians or radians to degrees. Let's put a 1 on the left. If I wanted to get a 1 on the left side, what would I have to divide each side by to turn that left-hand side into a 1? Yeah, Angelina? We'd have to divide each side by 180. Why don't you divide each side by the same thing? It's still true. You haven't messed anything up because you did the same thing on both sides. Now, it says this. One degree equals pi radians. That's a conversion from 1 degree. Okay, 1 degree equals, pi over 180. Forgot to write the 180. Pi over 180 radians. Now, if I wanted to know, let's say I don't want to know 1 degree. My problem says 3 degrees. Okay, well I can use this to figure that out. If I did, you don't write this because I'm going to change it. I just want you to see an example. If I did times 3 and times 3, now I have a formula that says 3 degrees equals, and I could type that in on my calculator and figure it out. How many radians is it? If I had to convert, if I had to convert 6 degrees, multiply by 6, multiply by 6. Now it says 6 degrees equals, and I have a calculation I could type in and figure out how much 6 degrees is in radians. The point is not what number you put in that box, it's that part right there. It's that pi over 180. So anytime you want to convert a certain amount of degrees to a certain amount of radians, that's the conversion that you use. You end up multiplying it by pi, and by it, I mean whatever you're trying to convert. You multiply the number of degrees by pi, and you divide by 180. That's how you convert degrees to radians. Now, radians to degrees is almost the same thing. Go back to what we had right here. This time, let's get a 1 on the other side. What could I divide both sides by here to get a 1 on the right? Okay. Get a 1 on the right. Okay. Pi. Let's divide both sides by pi. Pi, pi. Now you have a formula with a 1 in it. You like formulas with a 1. 1s are nice and easy to work with. It says 1 radian equals 180 over pi degrees. And if you wanted to know what is that actually, you could type it in. 180 divided by pi, that means 1 radian is about 57 degrees, if you round it off. Now, let's say I didn't want to know 1 radian, I want to know 2 radians. What could I do on each side of this equation to get a formula for 2 radians? Jess?
Multiply by 2 on each side.
Multiply each side by 2. Times 2 times 2. Now, it says 1 times 2, or 2 radians, equals, and you've got a calculation you can go do on the calculator and figure it out. Again, doesn't matter what number you put in this box. If you wanted to know how much is 12.5 radians, you could multiply this by 12.5, and multiply this side by 12.5, and then do it out. The key is what I just circled. If you want to convert from a radian to a degree, you take what you want to convert, you multiply it by 180, and you divide it by pi. The 180 is in the top, and the pi is in the bottom. So multiply by 180, and divide by pi. Now those two steps are very similar. One of them is multiply by 180, one of them is divide by 180. So it can be kind of easy to mix them up. Well, I have a way you can remember them, and you don't even really have to memorize this or that. The only thing you have to remember is when I say degrees, the number I want you to think of is 180. When I say degrees, I want you to think 180. When I say pi, I want you to think radians. So just kind of connect those two things in your head. Degrees, 180. Radians, pi. Okay, and then we'll go through some examples for how to convert that. So, let's try converting 60 degrees to radians. So, to do the conversion, you're always going to multiply by one of two things. It's either 180 over pi or pi over 180. You just have to remember which one is which. Think of 60 degrees as a fraction. You have degrees in the top of this one on the left. where would degrees have to go on the right to cancel out? Would degrees go on the top, or would degrees go on the bottom?
Bottom.
It would go on the bottom, good. So degrees has to go in the bottom to cancel out degrees in the top. And I want degrees to cancel out. I want radians in my final answer. I don't want degrees. I want degrees to go away. So that means degrees is in the bottom, radians is in the top. Now, I just said, when I say radians, what number do I want you to think of? When I say radians, you want to think, Ava? Pi. And when you see degrees, you want to think, what number? Yep,
180.
180. And that's how you can remember that this time the pi goes in the top and the 180 goes in the bottom. All because you want this to happen. Degrees cancels out. All right. Before I even multiply straight across, is there anything else I can reduce here? Yes?
The 60 and the 180.
Yeah, what's the biggest number? I guess you could pick any number, but preferably what's the biggest number that goes into both? 60. 60 goes into itself how many times?
Once.
And into 180?
3 times.
3 times. So you're left with 1 times pi in the top, and you're left with 1 times 3 in the bottom. And that is how you write your final answer. You might think I forgot something. I didn't forget anything. I didn't forget to put RAD. We don't write RAD. Right? I was just kind of showing you that kind of initially to help it make sense. So if you go to this program and you put it on 60 degrees, notice it says pi over 3. And that's the conversion between degrees and radians. And we just double checked it. Okay, any question on what we did there? So you'll notice I didn't really point it out, but if you drag it to most of these, it just gives you a decimal. There are some ones where all of a sudden it changes to a pi. And you'll notice the ones that it changes to pi are usually multiples of 30 or 45. That's a multiple of 30. If they want a decimal, the directions will say round your answer to whatever, 2 decimal places. Okay? Otherwise, we're going to be finding the exact answer, just like that. All right, let's try this one. 150 degrees. All right, Jacob, where would I want degrees to go this time to cancel out degrees here?
On the bottom.
Yeah, we would want degrees in the bottom, which means radians is in the top. I'm not going to write RAD this time. Just want you to pretend it's there, but it's invisible. All right, Lacey, what number do we always think of with degrees?
180.
There's your 180, and that means the other number goes in the top. That's RAD with pi. If this helps you, you can make 150 a fraction. Okay. Degrees in the top, degrees in the bottom, cancels out. How about Jacob? What can I divide both of these by? 150 and 180.
30.
Yeah, some people say 10, right? Because you can knock the zeros off right away. But if you go right to 30, it's perfect. How about Katrina? How many times does 30 go into 150? 5. Good. And how many times does 30 go into 180? 6. And that's pretty much your final answer. 5 times pi divided by 6. Any question on that? All right. Okay. Nothing changes when you do a negative. If you want, what you could do right away is put the negative on your final answer, because if it started as a negative, it's going to end as a negative. Right? And James, what would I multiply by All right, well, let's start with where we want degrees to go. You want it in the top or in the bottom? We want it in the bottom. What number did I always say? Think of this number when you think degrees.
I don't know.
Not sure?
No.
You want to help him out? What number do we always think of when we think degrees? Johnny?
180.
Good. 180? That's an 8, sorry. And RAD is in the top, it's invisible. But what's the number we always put with radians? Yep, Ava? Pi. And 45 does go into 180 evenly. Goes into itself once. How many times does 45 go into 180? 4. So the final answer is negative pi divided by 4. And so those are all examples of finding an exact answer. Let's do one where we round. So let's do round to 2 decimal places. So the calculation is exactly the same. It's no different than the last 3 we just did. Multiply by pi, divide by 180. The only difference is this time I'm not even going to bother reducing it because they sit around it. So just type it in on the calculator. When you type it in, make sure you use the pi button. Okay? Don't use 3.14. I'll show you in a little bit why. So 107 times pi, divide by 180. So you pretty much on this calculator, you type it in almost exactly the way you see it. And that's 1 point, if this is rounded properly, what would my answer be? 1.87. Okay, not 1.86. And it's approximate. Do I need RAD after it? No, we don't put that. The only time you have to label an angle is if you want it in degrees, then yes, you have to put the circle. But radians, no. Okay, any question on this? Okay, so let's finish up by trying a couple the other way. For the first problem, I'll write RAD just to help you get used to it, but we got to get used to it not being there. So now we're converting from radians to degrees. Forgot to start the video on that part. But we decided we needed to multiply by 180 over pi. And the radians canceled out. The pi's canceled out. And how many times does 6 go into 180? If you're not sure, just think of how many times 6 goes into 18. And then just put a 0 on it. Yep.
30.
30. Okay, I'll do another one in the video just to make sure I show all the steps. So all we're left with now is 30 with a degree symbol in the top, and in the bottom, just a 1. Now, could I leave my answer like that? What if I write this? What does that mean? Yeah. That's 30 radians, right? And we meant 30 degrees. So an answer like that would be wrong. It's totally different. It's like writing 12 inches versus 12 miles. It's totally different. So make sure you put the correct label, which in this case is the little circle for degrees. All right, we'll do one more of those just so get the whole process in the video. Remember, RAD is in the top, right next to pi. It's invisible. So RAD is going to go in the bottom. Degrees is going to go in the top. 180 is the number with degrees. Pi is the number with radians. Okay, RAD cancels, that's invisible. And Mateo, what else can I cancel?
Pi.
pi. Good. And we can reduce, how many times does 2 go into 180? Yeah, 90. Very good. 3 times 90 with a degree symbol. That's our final answer. So 270 degrees. So the last one, I told you I'd show what happens when you use the pi button versus not using the pi button. Let's do 3 radians. And we'll convert to 2 decimal places. All right, so that's how you'd see the problem written. We would just say convert to 2 decimal places, and up there, convert from radians to degrees. So same conversion. Multiply by 180, divide by pi. Let me do it with the pi button first, which is the way I want you to do it, and show you what you get. 3 times 180, and then divided by, use the pi button. 171.89. Now, if you don't use the pi button, the top came out to 540, and let's divide by 3.14. And we're looking for it to be accurate to 2 decimal places. So in this case, it comes out quite a bit different. To 2 decimal places, the top one is 89. The bottom one is 97. 89 and 97, that's pretty far apart. Okay, so make sure you always use the pi button. Right. Questions on that? Okay, so that's how we convert between degrees and radians. Okay, so that's the homework for tonight, page 99. 36 to 68 even. Okay, just the evens. So I'll check that tomorrow, and then we'll go over the second part of our lesson. Yes?
Do you have Friday paper?
Yeah, let me check. I think I have some in the map.